Good day everyone. This will be a next lecture about functions, and this is lecture B of functions, and we are going to talk about random numbers. Random numbers. Let's say, for instance, we want to create a program that will create random numbers for us. Now we need to break it down to the beginning. Let's say we ask a human being to get a random number. One person will say 2, the other person will say 101, etc. and etc. Humans have brains, and they can create random numbers by just thinking of a random number. In some cases, that random number is determined by some influences, but that's why we as human beings can also create paintings like the Mona Lisa, for example. Now, if we look at a computer, how can we tell a computer to generate a random number? Computers can't generate a painting like the Mona Lisa from itself. A computer only does what you tell it to do, and that's a problem. So what the mathematicians decided was, okay, we can create an algorithm that will give us numbers randomly. But let's say a simple algorithm, x plus x divided, or x plus x divided by 2 plus 3 plus y. If x has a static value and y has a static value, this algorithm will always give us the same answer. So how will this give us a random value? So let's look at the first part. To use the functionality of random numbers in the C programming language, we need to include a library called #include. We need to include it, and this library is called SFD201T Ch5. SFD201 stands for standard library, and it's different from stdio.h. Now, inside standard library, there's a function called rand. Okay, that function rand will create a random number for us by using an equation. So let's say, for instance, inside our main program, we have an integer. We have an integer called a, and a is equal to rand. A will have a random value of what this function uses. So this function will use a certain algorithm to determine a number for a. But now, as we said, if it's an equation, it won't give us actually a random number, because a computer can't just generate something from itself. Now, luckily, what they've decided in the generation of random numbers, they said, okay, for us to get a random number, we also need to give this rand function a seed. So what's a seed? It's a value that we give that function to make it more random. So let's quickly look at what's a seed. So a seed is a random value. We say srand, so we give the random function a seed value. Let's say, for instance, the value of 10. After we have given the random function a seed value, then we can go and create int a is equal to rand, and a will have a random value. So srand stands for random seed, or sometimes how we it's normally called also randomize. We randomize that function, the rand function. So now a will be a lot more random because due to this variable. But now this variable is also static. That 10 is also static. So will it give us a random value? Not quite. Because if the seed is known, we can determine what's the value. And so if the equation is known and the seed is known, we don't have a random value. So how would we actually go and determine a random value? Because this is not random. So how? So let's quickly think of what's the one thing in the world, in our beautiful world, that is never the same. What's the one thing in the world that's never the same? Question. And the answer to that question is quite simple. We all know it. Time. Time is always changing. Time from this second to this now following second will not be the same because a second has passed. Dates go on. It was last year 2016, this year it's 2017, the next year will be 2018. And on an exact time and place there will be a different time. So how would we use time to create a random number? So what we can do is we can randomize our random function that resides in stdlib by giving it a seed that is time. So how would we give it that seed? We just say time, and time is now also a function, and this is how you give it. Okay, this is how we will get a random number. So time is also a function with a parameter of null, and this will be our seed to randomize the rand function. Now after that, if we say int a is equal to rand, we will have a random number. Okay, so now that we can determine a random number, there's one problem again. Let's say if you are a magician and you ask the audience, give me a random number between 1 and 100. Okay, it's quite easy. Human beings then understand a number between 1 and 100. How will we tell our rand function to determine a random number between 1 and 100? We just now created a random number, but we don't know from where to where that number will be? We don't know. So how will we do it? And luckily for us, we have something called mod. Now, in chapter 2, in the mathematics, the normal C mathematics, you will see mod is shown as a percentage sign. Now, mod is actually just the remainder. Okay, remainder of division. Okay, so mod will give us the remainder of division. So let's say if we divide 2 with 3, what will be the answer? 2 divided by 3 is 0, remainder 2. Let's say, for instance, 4 divided by 3 is equal to 1, remainder 1. Because 3 goes into 4 once and 1 is left. Now, how will we use the remainder or the mod functionality to determine a number between something and something? For instance, 1 and 10. How would we do it? So, let's quickly look at how we will do it. So let's quickly start off by doing the following. Let's start off with 11 remainder 10. What's the answer? Or let's use division, sorry, just division. 11 divided by 10. 11 divided by 10 gives us 1, remainder 1. 10 divided by 10 gives us 1, remainder 0. 9 divided by 10 gives us 0, remainder 9. 8 divided by 10 gives us 0, remainder 8. And this will continue to 2, 1 and 0. 0 divided by 10 gives us 0, remainder 0. So any number divided by 10 will have a remainder between 0 and 9. Let's quickly do another example. Let's say we need to go and determine 5, a value between 1 and 5. 11 divided by 5 gives us, 5 goes into 11 2 times, remainder 1. 10 divided by 5 gives us 2, remainder 0. 9 divided by 5 gives us 1, remainder 4. 8 divided by 5 gives us 1, remainder 3. 7 divided by 5 gives us 1, remainder 2. 6 divided by 5 gives us 1, remainder 1. 5 divided by 5 gives us 1, remainder 0. 4 divided by 5 gives us 0, remainder 4. And this will be 3, 2, 1 and 0 again. So you will see this is repeating itself. 4, 3, 2, 1, 0. 4, 3, 2, 1, 0. So any number, doesn't matter how big it is, divided by 5 will give us something remainder, something between 0 and 4. And in this case, it will be remainder 4. So any number divided by 5 will give us a remainder between 0 and 4. Any number divided by 5 will give us a remainder between 0 and 4. Now, this is a very interesting fact. So let's exploit now this to get a random number between 1 and 10 now, for instance. How would we do it? So we can determine a random number. We can determine a random number. So let's say we have our program hash include SFD201T hash include stdlib.h for the random functionality, and also time hash include to give a time seed to our random function. Then inside int main we want to get a random value for a. And how would we do it? First of all, we need to randomize our function rand. So how do we do it? We say s rand time null. Okay, so we know that it is randomized. And then we can say int a is equal to rand, and we would know that it's a random value. Now, exploiting the fact that if we divide anything by 10, we will get a random number between 0 and 9. Or in the case of the 5 example, if we divide anything by 5, we will get a random number between 0 and 4. Let's do it. We mod our random value with 10. And now we know that this will give us a random value. Let's put it in comments. A random value between 0 and 9. But we want a random value actually between 1 and 10. Now, how would we accomplish that? Quite easily, we can do it by just saying, let's create another random value. We can say b in b is a random value between 0 and 9. And to just shift it up from 1 to 10, all we need to do is add 1. And this will give us a random value between 1 and 10. And that's what we want. And for your program just to end successfully, we can just say return 0. And this is our first example. This is how we would generate a random number between 1 and 10. Just for the fact that we can exploit the fact that if we divide anything by a certain number, let's say for instance now 10, we will get a random, if we divide the random number by 10, we will get a random number if we use the remainder between 0 and 9. If we divide by 5, we will get something between 0 and 4. If we divide by 7, we will get something between 0 and 6. And if we want to have a random value between 1 and 7, we only have to do mod 7. No, wait. 1 and 7, it's how many random numbers? 1, 2, 3, 4, 5, 6, 7. Yes. So all that we need to do is mod 7 plus 1. So we will shift this up to 1 and 7. Okay, so this is